Okay, thank you. Okay, so welcome everyone. Today, I would like to take the opportunity to answer some questions that you might have about the topics that I have explained during the course, some doubts that you can have about the project, and any sort of information you want to ask related to the course. So we have, we have in the schedule 3 hours. It's not mandatory to cover them all. If you have questions, drop me them in the chat. So the idea is that you write your questions in the chat, and then one after the other, I will answer your questions. If you want, I can record the lecture. I don't mind. It will be not as interactive as a usual lecture, but I will note down the questions anyway for myself, and if I manage, I will try to provide the feedback after the lectures if I'm not able to answer them all in 3 hours. So let me start recording. Here we go. This Q&A session. First, I would like to say a couple of things about the logistics, and then I will go into the chat and I will answer the questions that you will drop to me. There is already one over there. I will answer it in a minute. Before that, let me share my screen as well. Let me share this application. Here we go. Okay, you should be able to see my screen. And the first things that you see, just a second, that I will resize the view. Okay, you should be able to see the website of the course. And here we go, the schedule. So right now it is almost everything updated. What is not updated is the video from the lecture you had yesterday with Francesco Lattari. As soon as it is ready, and as soon as Francesco has reviewed the Jupyter notebook about yesterday lecture, I will share it to you here as usual. I will point the link to the Q&A session here in the course website. We left spare lectures here in case we needed to do more hours during the year, but likely we don't need. We ended up the program quite on time. So I will leave it there, but there will be no lectures in these days. On the course website, you see all the material already uploaded. What is missing? The only thing that is missing is the set of Jupyter notebook that yesterday was completed during the laboratory hours. So basically, that's the only thing that you miss. All the rest of the material is set up. You have also the link to the competition which is ongoing right now. Having said this, this opens the right timing to answer the first of the question in the chat. One of your colleagues asks me, what is the third challenge about? We would like to have a challenge about natural language processing, at least about text prediction or text, some machine learning task applied to text. So for instance, one thing that I wanted to do is a very simple chatbot. What does it mean? I mean that we could think about having a simple task similar either to a retrieval chatbot or a generative chatbot that you could face with a sequence-to-sequence model. So very basic thing. Then if you want to spend more time into, let's say, developing more complex models, maybe using attention or using different embedding, you are free to do that. So basically, this is more or less the set of tasks that we are planning for the third challenge. Okay. So there is another question is, can you provide us the third project in the next days so we have the possibility to do it before Christmas and not during January? Yes. The idea is to give it before Christmas, for sure. Not sure that we can do it before the 20th, but we can try to give it you before Christmas. Then it's up to you if you want to do it during the Christmas holidays or during the session. Personally, I would prefer you do it before the exam session, so you don't have to do it in parallel with the preparation of the other exam. So yes, I totally agree that we should give it to you earlier than the 20th. Right now, to be honest, we are preparing it because we are checking whether it is doable to give you a very simple chatbot or it is too complex. If it is too complex, we might resort to one project which is just very similar to last year one. Okay. Okay, there is a question about the project, which is, could you give us an idea on how to weight the intersection of a union? We changed a few models and still get the prediction as only background. We really don't know how to overcome this problem. Okay, this is very important. Unfortunately, Francesco couldn't be here, but if you can write a message to him, and he's answering students' email in batches, so he will not answer immediately, but it might be the very same day. So one important thing that I wanted to say is related to this. So some of you, and this might be useful if I help myself with just a second, with some drawing. So it is related exactly to this problem of let's do it this way. Let's open a blank PowerPoint, which is already. So how to weight the intersection of a union. As I mentioned last time, the one of the issue of the data set that you are working with is related to the resolution. Well, sorry, not the resolution. It's related to the unbalance of the classes. And because of this, what happens is that you end up predicting the most frequent class. What I suggested last time is to, so for instance, if you have this image, what happens is that often the most of it is background, and there is only one small item this way. So the output of this usually is everything as background, because what happens is that so this is the input and this is the output, because of this severe unbalancing that you get. So one possible idea, which is the one that I suggested last time, is to weight the background class with a higher weight with respect to the sorry, not the background class, sorry, the other way around, the foreground class. So you have to wait the forward, so forward, foreground, wait, then background. Now, another issue that some of you are facing is related to the fact that when you train a model, you get a validation error which is very high, but then when you submit your solution, you get an error, a result which is very, 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 very poor. This is one thing that is related to resolution. So let me discuss this. Let's assume you have a big image like this, and what you do is sometime to resize the image to the standard, I don't know, 100 by 100, 224 by 224. I mean, so one thing that people are doing is resizing. Then what they apply is a model. Let's assume that you use an encoder-decoder module like this, maybe with skip connection as unit or without skip connection, and then you get a mask like this of the same size. So I don't remember the size of the images. It might be that let's say you go down to 24 by 24, sorry, 224 by 224, and you come back by 224 by 224. And then what you do is to rescale the image at the same size. And this is rescale. So you scale down and you scale up. Now, this rescaling is important because the size of the output at test time has to be the same of the input image. The problem is that this approach will perform not so well. Why? Let me write it here. This is not the best approach. Why? Because by doing this resizing, you lose a lot of details. And what you do is that you risk to cancel very small items. And so basically, this resizing is not a nice thing to do. So how you deal with images that have these characteristics of being, let's say, of different size. There are different solutions. One is to turn the model into a fully convolutional one. But the more effective is this. Instead of resizing to a smaller image, perform segmentation. So this part is the segmentation. And then rescale. What you should do, let me do it in a different color, is to take the original image, then crop it in pieces which are 224 by 224. Many of these. And then for each of these tile, you apply your favorite encoder decoder architecture, and you get your segmentation. And you do it for all the tiles in parallel. And then you compute the full image by putting them together. So instead of resizing, I think that tiling is a better solution. Tiling. Now, as tiling, what you might find out is that if you look at this output, you might find some sort of stripes here. You will look at some stripes because in the upsampling and downsampling you have to do the padding, and padding is usually done with zeros, and this introduces discontinuities. So the suggestion is, instead of doing the tiling in that way, one thing that you could do is to do a tiling which is a little bit more smart, which is you tile with overlap. So basically you have one tile here, another tile here, another tile here, another tile here. So you overlap the tiles. You overlap vertically and you overlap them horizontally. And by doing this, you will see that you will get way better results. Otherwise, you will not get very good accuracies, especially because this compression step will remove a lot of details that then you have to rebuild with the rescaling, but it is not guaranteed that with the rebuilding of the details you are able to reconstruct the resolution of this. This is a second idea that I suggest you to test, actually even before testing the weighting mechanism. So this is tiling instead of rescaling versus scaling. And my guess is that your problems of very poor results will be solved, or at least will be fixed, because of this different way of performing segmentation. I hope this answer the question related to how to weight the intersection of a unit. Okay. Second, another question. This was a question by Alessia Mapelli. Now a question from Daniele Comi. It is, I have a quick technical question on the challenge. We have issues in creating the team on the CodaLab challenge. We have contacted the organizers to the forum, and they told us that that they technically use, and we need to create a team with a different name. So they told us to resend the Google form using a different team name. Is it fine for you? Yes. If you, this is not a problem. I mean, until so the organizers of the competitions are Francesco Lattari and Riccardo Bertoglio. So if you informed them for this issue with the team and the change of team, don't worry. If this is let's say tracked, it is not a problem. Okay. Okay, Niccolò, sorry, Mezzanzanica is, when will the result of the first challenge be published? I think that the results of the first challenge will be published either before Christmas or during the Christmas holidays. And the results of the second challenge beginning of January. That's the planned time of evaluation of the challenges. But I know that you are eager to know the results. I will push with Francesco the grading of the first challenge a little bit faster. Okay. Question. Okay, so I have a question regarding the challenge. Me and my team are working on mice dataset, but in masks I noticed that there are 4 classes: the background, the white, the width, and some images. There is another class that I cannot understand what is in orange or something. Is it correct? I thought there were only first 3 classes and I don't understand how to handle the 4th. There was a bug in the masks with one color. Try to re-download the images, whether it is that the issue. If this fix your problem, sorry for that. If it doesn't fix this, drop a message to Francesco Lattari and he will reply to your doubt. So yes, thank you for pointing this out. Okay. Oh yes, there was a question about publishing the exams on the course website. Yes, I will do it. I haven't done it yet, but I will sure do it before the end of next week for sure. There will not be too many. Probably there will be a couple of exams, 3, because the course has just started, and we will have probably to resort to online exams, not to classical written exams. So we only did 2 online exams up to now during this summer. So we don't have a huge literature of exam, but as soon as I manage, I will post them on the course website. Yes, thank you for reminding me this. Okay, there is another question. Oh, sorry, I lost the. There is another question which is about the homework. Sorry, the project which says prepare submission. The class asks for a NumPy and only 0 and 1 as input, which we do not have. Okay, it is a long question about from Alessio Colombo about how to prepare the mask for the submission. Can you please write that question to Francesco, because he is managing all this and he will reply you with the detail for sure. Okay. Another question still related to the project, which says, regarding the weight that we have to set for each class, can we exploit the argument of the sample weight in the Keras sparse categorical cross entropy, or we have to define our custom loss? No, you can use the Keras API. This is more to see your, let's say, your understanding of the models. You don't have to go down to the implementation of new losses unless you want. You can directly use the Keras API, for instance, the sparse categorical cross entropy. Go for that, don't worry. Okay. I have any other? Okay, another question. One question which is very long, but okay, let me read it. One general question about training. It happened more than once that the training got stuck since the very beginning, giving the very same validation loss epoch after epoch. I was wondering why this happens. Are we in a plateau? Why doesn't it seem to change if we choose a different way initialization? And which are the most effective way to tackle this problem? Does it make sense to change optimizer to use one which does not adapt the learning rate, just to get learning started and then later switch to a faster one? Are there any other approaches? Okay, that's a very good question, and introduces a topic which we did not just a second, let me make. Okay, first of all, if the training gets stuck, first of all, double check for errors. So the first thing is double check if there are errors in the code which prevents learning. This might happen if by chance you just change made a mistake calling one function or detaching something. So the first thing is try to learn with a few samples with very simple model and then grow in complexity. Sometimes it seems that it works, but you did a very subtle mistake and it takes days before you get them. So my suggestion is dismount everything, check piece by piece, and see if there is an error. I mean, this is one option. Second, another important parameter is the learning rate. So the learning rate if it's too low, what happens is that your algorithm doesn't move. So if the learning rate in principle is 0, you see that this is not gonna do anything. So first of all, check that the learning rate is meaningful. Sometimes the learning rates of 10 to the minus 4, 10 to the minus 5, 10 to the minus 3, up to 10 to the minus 2 are typical learning rates. And the other thing is check weights initialization. So weights int. Again, start do the usual Xavier or Glorot initialization as we already talked. We discussed about a few of them. Try to check that you did the proper initialization. Then another thing that might be critical is the let's say learning algorithm. Let's call it let's call it learning algorithm. It is not obvious that if you use Adam, you get the best result. Sometimes stochastic gradient descent does as well. So as usual, test different. So test stochastic gradient descent or Adam optimizer or what's the name of the other? rprop. I don't remember the algorithm. This name I don't remember. You have rprop propagation, but and that's you don't have to use them all. I mean, test with the different of them to figure out whether when you have problems, it is due to the algorithm. They might need a different learning rate. So maybe a learning rate which is good for stochastic gradient descent might be too high or too small for Adam. So if these are the basic parameter if things don't move, but usually if nothing works, the most critical aspect is this. There is some error that prevents gradients to flow. If still you don't have anything happening, try to debug with the tensor board, and you have tools to check the gradients magnitudes, which are already implemented. If you see that the gradient magnitude is 0, there must be some problem in your gradient computation, which might be, for instance, some errors in the model. I mean, you forgot to connect the two layers together or something like that. So basically, you don't have any gradient. Now that I have introduced all these parameters, let's go to the comment of your colleague. Can we start with some algorithm which does not adapt the learning rate, and then when we see that our model has moved, change the optimization algorithm? Yes, you can. Another things that you could do, usually this is done to improve the quality of the solution. Something that you would do if these are, let's say, epochs, and this is, let's say, the intersection over union. One thing that happens is that the intersection over union grows until it reaches a plateau. At this point, what you could do is to reduce the learning rate. What is observed is that sometimes this gives a speed up like this. I mean, what happens is that you had reached a sort of plateau here in the training, you re-init the optimizer and you reduce the learning rate, and what happens is that you gain a little bit. Possibly my drawing is a little bit exaggerated, but you can try to do this. This technique is called learning rate scheduling. Scheduling. There are already some functions in Keras which allow you to set learning rate scheduling. So, for instance, you say that during time the learning rate decreases by a certain amount, and you start with a certain value, you reach another value. That's a possible choice. Sometimes doing these manual reduction. So, for instance, you train for 10 epochs, then you small, then you reduce the learning rate, you restart and things get better. These are other possible techniques to improve the results. Okay, I hope these answers the question about what happens if my gradient descent gets stuck. There is another question. Have you proposed tiling as an alternative to grass weighting or as a plus to implement with it? Is a plus. I expect that tiling will get more improvement with respect to even grass weighting, but that's my personal opinion. For sure, tiling is something that you should do to get very high result. Is it okay if we train our model only on one of the 8 datasets, or should we use all of them? I told you you can do more or less whatever you want. Start with one dataset if you feel it more, if you feel more confident on that. Submit the solution. What will happen is that the solution will be bad on the other datasets, will be good on that one. No problem. When you will submit the final report, you say, I have focused on the beep beep images for the maze dataset. It is not a big deal. So don't worry, it will, you can use only one dataset. Okay. Is it possible to reach a grid accuracy around 90% or the dataset is too small? I love this question because I have no clue of the answer. Unfortunately, we don't have a history about this dataset. I mean, you are building the history of this dataset. We don't know how difficult it is, and we don't know how much we can push it. It is really done for you to test, practice, and for us to understand better the data. Right now, I think that the intersection of a union is above 70% for all the classes leaderboard. I don't know whether it can go up 80, 90 or something like that. Right now, obviously the dataset is small. I mean, it is still small, so don't get frustrated if you don't get the 90% intersection over union. But I would like to see how much you can push it. So I don't have an answer for that. I hope to have an answer for that after this. I must tell you one thing is that we just got an email from a UK university where a professor has asked if he can give to his students this challenge as a homework too. So probably there will be even more students trying to get this, and at the end we will understand what is the expected accuracy on this dataset. But right now I don't know what is the answer. Are there some efficient ways to evaluate our hyperparameter without using grid search? Not really. In a sense that there are algorithms based on Bayesian optimization and stochastic optimization that could optimize the parameters for you, but they evaluate many algorithms. They implement some stochastic search. There is a library which does this, but I don't remember the name. Let me write it down if I remember. Library for hyperparameter optimization. If you want, I can spend 1 second to make a search for this. Let me see if I okay, there is, okay, one library is this, and then another one is this. Okay, there are, and this is the stochastic one. I mean, there are some libraries. I'm looking at those with you for the first time. H-params is one of these, which allows you to test. It's very similar to the grid search. You tell what are the metrics you are interested in. You tell what are the range of the parameters in terms of, for instance, number of units, the level of dropout, type of optimizer, and he does the work for you during the night. Don't get mad with this. I mean, try to do some hyperparameter yourself to better understand the problem. If you have computing power and time to play with hyperparameter tuning, one possible library is this H-param. Let's see. There is another framework, which is this Keras tuner. The idea is more or less the same. You tell what are the range that he has to test, but it is not really different from the grid search. Slightly different is this Bayesian hyperparameter optimization, which does let's say it does smarter search instead of a grid search. If you're curious, check for it, but my suggestion, at least for this project, don't get mad with this. Don't worry. Okay. Is learning rate scheduling a manual process, or it can be automated? It can be automated. So if you are curious, just make a query. Let's stay on TensorFlow. Learning rate scheduler. Oh, okay, no, but let's. So you see, you can use a scheduler. So you say, okay, schedule the learning rate this way. So basically, what you do, you start with a certain learning rate, and every X epoch you decrease exponentially the learning schedule. So what you do is to set this scheduler by giving the parameters on how fast it has to decrease the scheduling and so on. If the question is, can't we, by just looking at how the learning is going, automate the scheduling process? Yes, we can, in the sense that we can monitor the training error, and if we see that we reached a plateau, we change the learning rate automatically. Yes, you can implement some sort of automatic scheduling like this. Usually, what is effective is that you stop because of early stopping, and at that point you restart from there by a decreased learning rate, and you stop again by early stopping. So basically you interleave the early stopping technique and the weight decay, the learning rate reduction to reach a better optimum. Okay. Okay. Are there other deep learning or reinforcement learning course at Politecnico? Maybe for PhD? Yes, there are, but not every year. So every year there might be a new course on deep learning or machine learning for PhD. It may vary depending on the year. This year, I don't know. I mean, you have to check in the computer engineering program, there is a table which is a dot, which stands for PhD in Italian. And in that table, you see the PhD courses for that year that you can take. Check over there. Okay, do you have any suggestion or strategy to understand which lever to freeze when doing transfer learning? That's a good point. I don't know whether I showed a slide to you during these days, but if I didn't, let me check if I have it somewhere. So there is, let me check if I can get to it fast. Just a second. It is okay. Let me check. Okay, let's see here if I have the slide I am looking for. Let's see if it's here we go. Yes, this is the slide I was thinking for. This is a slide which gives some rule of thumb, very rule of thumb. So don't take it as. So usually when you decide where to stop let me where to freeze the levels, the rule of thumb depends on how much data you have. So let's assume you have a small data set, I mean, few hundreds or a few thousand of samples, and what you would like to do is to keep the most of the frozen architecture, the most of architecture frozen, and you only train the last layers, which means the last fully connected and the softmax, or even just the softmax. So when you have a small data set, you freeze the most of it and you only train that. You can also schedule this. So for instance, you train only the last part and you keep it the first fixed, and then when you have converged, you start unfreezing a little bit of the rest, and you fine tune until you freeze it, let's say unfreeze it all, and you fine tune everything. But usually when you are with few data, what you do, you only train the last layers. If you have a medium data set, you can push it a little bit back. So what does it mean? It means that you can also adapt, if you have a medium data set, you can adapt also the feature extractor before the fully connected layers. The tip that is given in this slide is to use very small learning rate. So notice, if you have a small data set, freeze the last, and then if you have bigger data set, go back after training the last layer. But the tip is to use maybe in the layers which are here, a learning rate which is 1/10 of the original layer, which was the one on the left. So basically, and then if you go back, you use a learning rate which is 1/100th of that. So usually you do exactly what I said before. Start with this, then you can enlarge, then you can enlarge, and then you can enlarge the fine tuning, but try not to let's say destroy too much the weights in the back. This means that you let me go back to the slides, which might be useful now to move. So me get a couple of blank slides. So at the beginning, if you have a deep architecture like this, so if this is the feature extractor of VGG, and here you have the fully connected layers, and here you have the softmax, if what you do, you freeze everything, freeze, and you train with a certain learning rate. Then, if you have a significant amount of data, you can start unfreezing in the back, freeze. Then you have these with this is gamma to the -1, and this is gamma, and then you can go back to, I don't know, even half of it. I mean, you don't have to unfreeze all. So you have this, so you get gamma to the -1, gamma to the -2, and you freeze up. But this is the rule of thumb for the learning rate. As for how much you can or you should unfreeze depends on the number of data you have. So that's one suggestion. There was a comment on the chat about Scott. I think it's another optimization framework. So Shikit optimized, which is again sort of Bayesian learning, Bayesian stochastic, let's say, optimization for the hyperparameter. So basically, you can do some cross validation, and here we go, Bayesian optimization for the hyperparameter. So what you do, you build a model on how your model behaves varying the parameters, and then you optimize based on that model. Thank you for pointing this out. Okay. Question on training in general. Is it correct to say that using bigger batches improves the performance of computing the gradient, and so in reducing the loss, or there are cases in which this gives problems? Okay. Usually, what you can say about bigger batches is that they improve the smoothness of the gradient, because I mean, when you have a stochastic gradient descent with one single sample, you will have a very noise estimate of the gradient, and when you have a given batch size which is quite high, the gradient is very, very smooth. So as an answer, bigger batches improve the, let's say, smoothness of the gradient. There was an interesting work recently which was trying to show that big batches are worse than small batches. But then I don't know whether I pointed out during lectures. So batch size and convergence. Let's see if I find it again. But basically, it was only a conjecture. Let's see. Here we go. I think that is, but I'm not sure. So it seems that it learned faster with the, let's say, small batches with respect to, let me see if I have a feature, which with respect to big batches. But actually, this is not true. In a sense, let's see if I get the pictures. No. Oh, here we go. So it seems that let's see if there is no legend anyway. So it seems that based on the uh, size of the batch, you get to a different result. Okay, orange curve is a small batch, a blue curve is a bigger batch, and purple curve is. So by looking at these plots, it seems that the bigger the batch, the worse it is. Actually, the answer is that it is not true, in a sense that if you keep the learning rate unchanged, it is true. But if you adapt the learning rate to the size of the batch, then you see that they converge to the same effect. So in this case, you have in orange 64 with the learning rate of 0.01, purple with 1024 with the same learning rate. But if you increase the learning rate, you see that the orange and the blue are the same. So basically what happens is that it is a trade-off between learning rate and batch size. So in general, you should use as bigger batches as you can, and then as you see, if you find the proper let's say the proper learning rate, it will converge as fast as the other. So that's I will skip why this happens, but basically the answer is you don't lose anything in doing big batches. Actually, it can just go better. So that's it. Okay. Can we get a bonus point if we get better scores than the other university students? No, you can't, but that's a nice thing. Thank you. We have tried to use an implementation of UNet, but it is really expensive in terms of memory, and we can't batches bigger than one image, keeping the original size, and so it seems to perform very poorly. Does it make sense to use it in these conditions? Well, what does it mean to keep the original size? You can try to reduce the size of patches used and use tiling. I would be curious to see how it works. So don't quit using UNet. I don't know if I said it before, but UNet is my favorite topology for segmentation. So I would like to see it performing very well. It might be that you need to use very small tiles, like 100 by 100. Now the question is where this cost comes from. Well, probably because of the U connection. So you know that UNet just does something like this. Then you have the shortcut, and then you have this. You have the upsampling, and then you have this shortcut connection, and then you have the upsampling, and you have this shortcut connection. Now, one thing to reduce the number of parameters is here to use bcubic instead of transpose convolutional. Transpose convolution. Why? Because bcubic doesn't have any parameter, while transpose convolution has parameters. And another trick to reduce the complexity is also to do to start from a VGG here. So you start from a VGG, so it is a pre-trained architecture, and then you use like a VGG as a backbone. But now I see that the original size means that you give as input an image which is 155 and 36 times 2038. No, you definitely need to tile. So my suggestion is to downscale the unit to handle patches of 224 by 224 and use this downscaled input in order to keep the model simple and to be able to keep the resolution high. I don't know the outcome, but why I'm suggesting 224 by 224, because if I'm not wrong, is the size of VGG. So one thing that you could do, you could use like VGG layers, pre-trained VGG layers as input to your unit, and then you let's say build them this way. But that's just an idea. Don't take it as the solution, please. Another question is, do you suggest tiling in place of rescaling even in the case we are downsampling the training input? And in the case of our challenge, even the mask, we risk to lose important information even downsampling an image. That's a very good point. So one comment. What you gain with deep learning does not cancel what you learned from information theory. So what does it mean? It means that if you have a very low signal to noise ratio, or where you have very high frequency information, if you downsample and use this very high frequency information, either you have a way to recover it, or I mean, you cannot ask the magic to these models. So downsampling is a reasonable approach. If you do it, don't forget to use some form of interpolation. For instance, either a bicubic interpolation before downsampling, or a k-nearest neighborhood interpolation, or something like that. But I expect at some point to I expect some point tiling getting better than subsampling. One important thing that might help you is that I mean, you have 4 data sets. They are very, very, very different, and depending on which data set you use, maybe that you have significantly different resolutions. I mean, impressively different resolution. And it might be that a plant in one of these sample is 100 by 100. In this sample is 256 by 256. In this is 20 by 20. And in this one, a plant is 10 by 10 pixels. I mean, if you want, in this case, makes sense to downsample the images in such a way that all the plants and all the cues have the same size. I mean, this makes perfect sense. And this will allow to develop a model which is, in a sense, insensitive to the size of this. So just to answer, if so we risk to lose important information even downsampling. Well, if the resolution is in this case so big, I mean, if you downsample, each plant will keep being big enough that you don't lose information. But if the image is very, very small and downsampling, you end up with a plant or a weed which is a few pixels by few pixels. This might lead to reducing losing information. So again, it is true that with deep learning you just throw images to the algorithm and it learns, but this is not really true if you want to get very good performances. Spend some time looking at the data, or focus on one data set. because if you want to work with many data sets, you just have to look at them, figure out what are the characteristics, and then adapt your model to be, or at least to have the chances to be robust to different resolution, lighting conditions, and so on. So again, look at the data. That's my best suggestion in this case. One comment: sometimes when we're using pre-trained models, we don't get the mask size exactly as large as the input after the decoder. Is it okay to resize the output given by the network with careful interpolation? Yes. So just why this might happen, because maybe you have a model like this and you have a mask which is, let's say, smaller by 2-4 pixels for some reason. Can you interpolate? Yes. Why not? I mean, this is perfectly fine. My suggestion, if it's possible and if it makes sense, add the interpolation in the training of the model as well. So basically, so for instance, if you have a pre-trained UNet like this, which gets, I don't know, 224 by 224, I'm just making this up, and outputs with 212 by 212, just add an interpolator here to become 224 by 224, and then train in such a way that you optimize also for the presence of this extra layer. You could do also afterwards. So what you do, you can do it after training, before submitting the solution, you update this. But it might be smarter if this layer is differentiable, which, for instance, the bicubic is, then you can add it there and refine your model. In order to tile the images, it could be better to cut the mask and the images, creating a training dataset with all the images and the mask cut, or we can maintain the dataset as it is, and both the cutting and the rebuilding operation have to be performed every time an image has to be fed in the net. This is a good point. In a sense, is left to you. In a sense, so let me clarify. Okay, let me get. So there are both options. So one is to rebuild a new data set. So for the one of you that didn't get the point, so let's assume you have. Let's make an example. You have two images. And you want to build to train them with the network, which takes half of it. So one thing that you could do, you could keep these two images in the hard drive, and every time you get these two images, what you do is you get the image, you split it in 4, you add it to the same batch, you give it to, I mean, both the image and the mask. I mean, you give it to the model, and you get the 4 masks. And you can do it online when you feed the network. Or there is another approach which does something like this. You have the two images here. You build a new data set stored in the disk, where you have 1, 2, 3, 4, 1, 2, 3, 4, and then you directly sample these images from this new archive before giving it to the it depends on the size of the data set. Usually, if you do it first, you save the computational time of preparing the images, but it might take a lot of space. So sometimes you go for the first one because it is more space friendly than the second one. It is also true that if you do exactly this way, in any batch, you might end up having always the same image, while adding some variety to the batch might be a good thing. So, for instance, you might, you might get one image per class or per data set. You split it, you sample the tiles, you mix the tiles, and you put them in the batch. So you don't have a batch which is made of all the same image, but you have the batch with the different, let's say, pieces of different images. And this might give you more variety at training time that will make the network sometimes more robust than using always the same image. Okay. Okay, there is a question which says, I've seen that we could use a TPU on Google Colab instead of GPU. Does it change a lot performances? Do we have to process the data different from using it? I don't know. So when you say performances, I think that you refer to does it learn faster or not? This I don't know. TPU are the accelerator that Google has developed for its own servers. So in principle, they should be faster, but I have not experience on TPUs. I hope, but I don't know, that for you, you don't have to change that much. So basically, if you don't have to change it too much, you can give it a try. But I don't know exactly uh, what is the real trade-off, what are their performances. We don't use them, so I don't have a personal experience on that. Any other question? Doubts? You can ask me also about, I mean, topics that I've taught during the classes, not necessarily about the project. I mean, it is a very broad and general question and answering session. I mean, it doesn't have to be strictly related to the project or the homework. I mean, that's it. Okay, I don't see many answers. Sorry, questions. Okay. So are there any sites where we can remain up to date about new researchers on deep learning and neural network? Right now, new researches on deep learning and neural network, they come up every day. I mean, there are a lot of resources, either scientific resources, which means journals and conferences, either more, um, let's say dissemination oriented resources like blogs and like a Medium or toward data science or other kind of blogs, or maybe some more technical sites like I don't know, I'm thinking about Stack Overflow or Stats Overflow, like that. There is a lot. There is a lot of to follow. I see a link which is Papers with Code. It is only one of the possible sources. It's not the only one. The only thing you have to do is to monitor, I don't know, blogs or periodically check. The literature on deep learning is more than huge. I mean, it is huge and varying. And sometimes what happens is that you find papers which say, this is the revolution. And then the week after, this is the revolution. And then the week after, this is the revolution. and none of those revolutions will stay on for a long time. There are many. I mean, I see that people are pushing blogs and links. I will not endorse any of them, but I think that any of them is the one possible way to stay up to date. Okay, which is the bicubic layer you were mentioning? I can see upsampling TD, but not interpolation. It has only nearest and bilinear. Sorry, I said bicubic. You can use upsampling bilinear. I wanted to say bilinear, not bicubic. Sorry. Thanks for pointing out. Another one is I tried to change the loss function to enter the balance in the input targets, and while its domain is 0,1, it starts from 0.0038 instead of 0.7 of cosentropy. Should I increase the learning rate or multiply the loss function? Okay, so don't worry of the absolute value of the cross entropy or the absolute value of loss function where you have put the weights. Try to check what happens to the accuracy. And even more important, try to check what happens to the confusion matrices. That's one key point. So the absolute value of the cross entropy or the absolute value of the weighted cross entropy might be very different. But at the end of the day, what really matters is the accuracy, the precision, and the recall. So check those. So my suggestion is to do that. And this is something, yes, please. I mean, if you have time to play a little bit, try to plot the confusion matrices that are basically matrices where you have a matrix where you have, for instance, the predicted and the true class here, and basically you get the number of samples predicted from class A, which have been predicted as class A, the number of samples predicted as class B, which get predicted as class B, the number of samples of class C, which gets predicted as class B, and the most of the values should be on the diagonal. So each class should be predicted as it is. If you see off-diagonal elements, then you start seeing some, let's say, bias or some errors that the model does. It might be because those two classes are very similar. I mean, it's quite obvious. And then you realize that maybe that you get very, very high accuracy, but because you are just predicting everything as a background, if you count also the background as a target class, and it is way, way, way more frequent. So one thing that you could do is to plot these matrices and plot these matrices while you train, and on TensorBoard, if you check, there should be for sure some code online, and these are more useful than accuracy. Try to see whether it can be done, or just at the end, try to monitor this to see if there is some critical class for which you don't get very good result. Okay. One question which says, do companies ask for deep learning models for other tasks than those implying images and time series, even if those models are kind of black boxes? I mean, models we could maybe implement with machine learning techniques, but with poorer performance than with deep learning. Well, so that's not an easy question. So, for instance, right now, a lot of companies are searching for people with a background in natural language processing and using deep models for text. I mean, right now that there is a huge demand. I mean, I I personally get companies writing me emails that they are looking for students which background on this topic because they have tasks like this one. Uh, right now, these text and images are the two fields where deep learning is mostly consolidated. There is another task or data which nowadays is getting a lot of momentum, which is graphs. So applying deep learning models uh, on graphs. And these recent 2 years, we have seen a sort of explosion of models on graphs as data structures that can be used, well, can be faced with models using deep learning. So usually the data for which deep learning has proved to be very, very, very effective are those data for which there is not a clear, straightforward tabular encoding. Images, text, time series, graphs are some of these data type for which deep learning nowadays is gaining momentum. Companies sometimes they have problems and they don't know what to use. Other times they go behind fashion and they say we have to use deep learning, even though machine learning techniques could work even better. I mean, it will be up to you to look at the problem they have and suggest the best model to use first. And second, my suggestion is not to go for let's say one particular model ever. I mean, test many, start from a baseline and evaluate every other technique, either machine learning technique or deep learning technique against this baseline. Uh, just a comment. Did any one of you tried to segment the images of the competition with green cluster and then use the cluster, I mean, to get the bounding box and get and classify the pixel based on the size of the bounding box? I don't know if someone did or not, but how does this perform? Because if this performs better than any of the algorithms based on deep learning, why not using just that? So I think the deep learning and machine learning are very fascinating, but you should never forget you're an engineer. And so, I mean, you have to base your decision on quantitative evaluation. That's why we keep telling you cross-validation, metrics, evaluation, test, training, optimize the parameters in an objective way, because they make the difference. Sometimes the difference is because you have chosen just the wrong way to evaluate. And this is a very important aspect. Okay. Are there other questions? Oh, let's see. So earlier in the course, you mentioned the Turing machine and that R and N can approximate their behavior. Why is this important? I have never directly studied the topic, but I was curious. Probably, so this kind of question somehow spoiled the fact you're not a computer scientist. Am I right? Yes, okay. Don't worry. I mean, no one from computer science would ever missed studying Turing machine. Uh, why? Just joking. Turing machine is an abstract model for computation, which is often used in theoretical computer science as an abstraction of a class of computational problem that cannot be solved by easier machines. So, for instance, you have a finite state automata. You have a finite state automata with a stack, and then you have a Turing machine. And the class of problems that can be solved are one nested to the other. So they are not real physical machine, are more models of computation, which then gets associated with the class of complexities. If it sounds really abstract as an explanation, it's because it is very abstract. It is the base of theoretical computer science, and if you're curious, I point it to you, to that. Okay. Okay, there is another question, which is, for generative adversarial network, is it possible to get rid of the generator instead of the discriminator in order not to generate images data from random noise, but to have a sort of fake image data detector? Yes, in a sense, what you could do is to, let's say, use the genetic adversarial network to train a discriminator instead of the generator. I mean, this can be done. Right now, immediately, it doesn't come to my mind the application, but the answer is definitely yes. Usually, generative adversarial network are used mostly for finding a proxy for a complex loss function. So instead of deriving the loss function for the generator, you use the discriminators as use the discriminator as a loss function for the generator. So one example could be detect deep fake videos or images. One thing that you could do in that case is to use the generator and classify the generator. Well, yes, you use the generator and classify the output of a generator with the discriminator. But in this case, basically you are training a classifier. You have, so it is not really different from training a classifier if you keep the generator fixed. The interesting part of GAN is that you evolve also the generator, taking into account the discriminator. That's the tricky part. But yes, you can just keep the discriminator and just keep fixed the generator and use it to train a discriminator. But in that case, you are just training a classifier. But yes, you could do it. I mean, it's one possibility for sure. Okay. So it is 6. I would like to take a break. We have another hour of question answer. I mean, if you don't have questions, we don't have to fill it up. Don't worry. But what I would like to do is to stop here, take 50 minutes of break until 6:15, and then I'll come back to here. In the meanwhile, I will stop sharing and I will pause the recording. So if you have questions after the break, just post them on the chat and I will answer to you. Okay, see you in 15 minutes. Thank you. Hello, welcome back everyone. Can you hear me? Okay, thanks for your feedback. Let me share again some blank slides. So if I need some, no, sorry. If I need to share some notes, I can. Okay. And let me resume the recording in case in case someone is interested in listening this question and answer session offline. So before the break, I was asking you whether there are other questions or not. Okay. 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 Two questions, very interesting, very applied question. I will start from the second, then I will go back to the first. The one is, are people actively researching ways to include logic and reasoning in deep learning? I found very few articles about it, but I don't often hear about this. You touched a very sensitive topic, sensitive in the sense that I'm very interested in this topic. There are different ways to face it, and some of these are trying to learn logical clauses in a more classical machine learning approach. In other cases, there are some works in trying to add some learning part to the logical one. And some other, which are the parts I'm most interested in, are trying to build hybrids by building differentiable algorithm. What are differentiable algorithms? Well, let's assume that you have two blocks. One is a neural network, and another one is a classic algorithm, where algorithm, I don't know, let's take a sorting algorithm or some pathfinding algorithm. I mean, some classical algorithm or an optimization algorithm. So if we manage to compute the derivative of the algorithm with respect to the input, then we can train end-to-end the whole pipeline by backpropagation. For instance, this algorithm could be an inference algorithm. So I think that this is a very fascinating topic. There are, as you correctly say, there are not so many algorithms doing this, research doing this, but I think that hybridization between top-down reasoning and bottom-up reasoning would be the next. But this is my personal opinion, which means that I'm not such important as a Hinton Benjo or those big guru. I mean, it is the kind of answer I would like to provide in my research. I have a PhD student working on this topic, and I have also a master student doing a thesis on this topic right now, where at the current time, this is an A-star, differentiable A-star algorithm, and he's trying to do this. And I mean, I have some work on doing on that. There's a follow-up question to this, which is if I have thesis on this topic. I take this opportunity. Some of you have written to me asking for thesis proposals in the last 2 weeks, and I didn't reply to any of those. Not because I'm unpolite, nor because we don't have thesis. The reason is because we are at the end of the semester and it is a crazy period. So I'm giving priorities to close up many things. I will reply about thesis proposals to the people that have written to me, but I can give you already an answer. What I usually do is have a sort of workshop, like half a day of thesis presentation, beginning of February, so middle end of the exam, possibly to the end, and someone has opened up the audio. Please switch it down, otherwise I have thank you very much. So basically I will have a workshop where I present the thesis. There might be some on this topic as well, but on other topics, some of those are maybe with companies. If you're interested, drop me an email. I also thought about using one of those spare lecture days to present these theses as well. That could be a proposal. But I think that being close to the exam session, doing it now or doing it at the beginning of February doesn't change too much. So I would prefer to collect as many theses as possible and then propose these during an online meeting to all the interested students. So the answer to the question, do you have any thesis proposal on this topic? Yes, we might have one or two on these and other things. If you're interested, I will have a thesis presentation in beginning of February. Now, another question is, if you want to use a LIDAR sensor, which give a 2D map of distances to measure the height of objects, weight, people, and so on, would it be possible to use a neural network for this job, given that I have a small data set? Or it would be more efficient to calculate the height by some handmade algorithm, knowing the inclination of the sensor? Okay, that's a good point. So so basically, I mean, one thing that you could do is to place the sensor like this, and based on where the distance and the position of the points, or put it from the bottom and do the same. My suggestion is to start with a handmade algorithm. Especially if you have a few data. And once you have it, you have a reference model. Then you can try to set up a machine learning or a deep learning approach, but then you have to decide for the encoding of the input and whether you treat them as a sequence and so on. So in principle, yes, you can do it to compute the height of the person by learning. And if this person or this item moves under the LIDAR, you can take it as a sequence of points and try to predict the height of the person instead of measuring directly. But I mean, again, it is something you have to study a little bit more, starting from a standard thing. Another question, what is the difference between your research and I imagine thesis on deep learning and Professor Boracchi's one? What is the difference? I mean, we are interested in different problems, different applications. Boracchi's thesis, they are mostly about images. Mine are both about images and all the application of sensors to robotics and autonomous agents. I have thesis also with some companies on natural language processing and some thesis on anomaly detection as well. So I would say that they are kind of similar. They are alternatives. So I point out to ask both and to attend both presentation. I mean, and this is a general suggestion. Choose the thesis that intrigues you more. I mean, select the thesis based on the topic, on whether you are fascinated by the topic, whether it's interesting, and go for that. The reason why I suggest this is because theses are a piece of work you will spend 6 to 12 months on. So you have to like it. And so my suggestion is choose something that you like. That's it. So then I would have no easy way to distinguish my thesis from Boracchi's one, despite go talk with both and then choose the one you prefer. I mean, I'm pretty open. Mine, I have more thesis on robotics than what Boracchi has, and Boracchi has more, let's say, classical image processing than me. Okay. Are you dropping an email to allow us to let know more information about the workshop, or do you want to send you an email to let you know we're interested in? I would prefer you to send me an email if you are about to start the thesis next semester. If you plan to start the thesis 1 year from now, don't worry. Drop me an email later on. There will be another workshop in, I don't know, end of the summer, beginning of September. So, I mean, don't ask a thesis a year before. I mean, makes totally no sense. Start the thesis when you ask for a thesis when you are close to the time you are going to do a thesis. So that's my suggestion. Otherwise, I mean, I don't mind to present thesis in front of 100 students, but it is better if you first focus on the exam, and then when you are close to the end of your studies, start looking for a thesis. No reason to do it before. Do you have thesis in collaboration with other universities? So my thesis works, they depend on the time. So what does it mean? Sometimes I do, sometimes I don't. I have a new thesis on average 6 months. So right now, I have some thesis in collaboration with some, let's say, companies, some of theses which are within some research projects. I have a collaboration with other research groups in software engineering and cloud. My suggestion is if you want to do a thesis, even with, let's say, only partially related to machine learning and deep learning, get in contact with me and we will see. I mean, I don't promise anything. I mean, I don't promise a thesis for anyone because simply I cannot handle thousands or hundreds of students. But on the other hand, I'm kind of open to this. Do theses in the company make us lose points? That's a very good question. Thank you for that. Okay, this is a very thing. I mean, very general. So, what does it mean to lose point? You know that Politecnico di Milano has two kind of theses. You have a thesis with reviewer and thesis. Sorry, and without. The difference is that in the first case, you need novelty, innovation, novelty. In the second case, there is no need for novelty. So, for instance, you can just implement a novelty, implement a model which exists. No novelty. So basically, it's more an implementation and let's say more close to a project than to a thesis. Without a reviewer, they can get up to 7 points. And without a reviewer, they can get up to 4 points. The tricky part is the novelty. It takes time to find or to, let's say, develop novelty. And time because you have to, first of all, be aware of the state of the art, implement the baseline, implement the state of the art and compare your proposal with the state of reality. If you don't compare with something that existed, it is hard to tell that it's novel. I mean, it's unless it doesn't exist at all. So usually they require more time, the natural time that it takes to do things which require. My experience is that on average, a thesis with a reviewer takes at least 9 months. And what happens is that until month 6, things are not clear where the novelty comes. And then after, on average, 6 months, everything changes. And I mean, I have right now, but it's an experience that happens to me every time. People struggling to graduate in 9 months, which decide to not to graduate immediately and graduate in 12. And in those 3 months, I mean, it's downhill. Things finally work. Why? Because it takes time to generate novelty. While if you just have to replicate some result in the literature or to implement state-of-the-art technique or verify that some results that exist in the literature can be applied in a use case, then this is easier, not necessarily leads to novelty, and usually it is faster. So the question is it possible to do the thesis in 1 semester? Well, it depends which one of the two. For the second, I am saying yes. For the first, I'm saying difficult, very, very, very difficult. But not because of me, because of the natural evolution of things, where finding novelty is a difficult thing. And I mean, providing innovation in this field requires, let's say, a sort of fermentation before it can get something. So if you ask, I want to graduate in 6 months, my first answer is go for a thesis which is replicating state-of-the-art results in a problem, which doesn't mean that the novelty doesn't come up, but sometimes getting novelty requires more time. I mean, it's a natural thing. Now, the original question. Which thesis, so how do we map these two with the companies? It really depends, in a sense that there are companies where we have, with which we have collaboration, strict collaboration, in which we do research. We, in general, I mean, it's not just me. And in that case, since I mean, the company is interested in the novelty, then at the end you get a full grade because you get a thesis with a reviewer. Sometimes it happens that the students find themselves a company to do a project with, and the company doesn't care about the novelty. The company cares about the results, and they just ask the student to take a little model from the literature, apply it to their own problem, and if the novelty happens or not, they simply don't care. Are these bad theses? Not at all. I mean, they give you a very nice industrial perspective on machine learning and deep learning. They introduce you to an industrial setting. Half of the time, you get hired by the very same company. I mean, I have many experience on this. But sometimes, I mean, because they are highly job oriented, they end up to be fast, and the novelty is not the main goal, so end up in this. So the answer is, I mean, it's like metrics like this. Sorry, let me do it. So you have reviewer, no reviewer, and then you have university and company. Now, this matrix is full. I mean, you can have thesis in company with the companies or within companies for which you have no reviewer, some for which you have the reviewer, some in the university for which have a reviewer, some for not. Who decides? Well, sometimes is you, in a sense that you want to do fast. You don't care whether it's 4 or 7 points, and you usually ask for a thesis with no reviewer. Sometimes is again you, which says I want to do it with a company because I want to be hired by the company. And sometimes is the event. You start with a thesis university as a reviewer because you wanted to spend a lot of time. Then it turns out that you want to be fast, and you say, okay, I will stop here and graduate with no reviewer, even though I don't get the full mark. I mean, it is a very flexible condition, and I have both students with companies with reviewers, with companies with no reviewers. With me in the university, me means with me, my PhD student, with no reviewer, and with reviewer, I don't. I mean, there are works which are more suited for the second. So right now we have a collaboration for a company in the automotive field, and they want to be able to detect traffic signs, lines, and things in images. I mean, this is application of standard models on very huge data sets that I obtained, and this. If you just do this, so take it's like an improved project, but with like some dozens of gigabyte of data, then it is a more an implementation work. If you figure out that this work cannot be done and you need to do some innovation for that, it becomes a thesis with reviewer. So I'm very open to discuss with you the different options. So that's the real answer. A little bit complex, but there are many opportunities for you. That's the point. And this is true for any colleague of mine. I mean, it is. I think that you will get the same answer from Boracchi, from I don't know, Restelli, from other professors in the university. I mean, it's not different. It is not who you do the thesis with that decides whether it will be with reviewer or no reviewer. That's I mean, obviously the distribution in these metrics is not uniform, but I mean, this doesn't mean that it has to be like that. Okay. Other question? Just a second, sorry. Questions. Is this thesis on automotive sector suitable also for mechanical engineers? It's not on mechanic, and it's not in modeling. It's not on control. I mean, it is a thesis on machine learning and computer vision. I mean, that's something that I have to stress. I mean, I'm not a mechanical engineer. I'm not a control engineer. I'm a computer scientist, and I work in AI and robotics. So it will be on those topics. Okay. Okay. No, if you you missed the answer. You're right. Probably I was not clear enough. If you want to get information about thesis, you have to send me an email requesting for that. Don't do it 1 year before when you want to do the thesis. I mean, do it next to when you want to start. I mean, if you want to start the next semester, it is a good time. If you want to start the second semester of 2021, send me it later, not now, because it will be too early. But yes, send it to me. I will not like to spam everyone with the thesis proposals. Otherwise, okay. Okay, if we want to try the thesis abroad, we should first find something in the target university and then discuss with the professor at Molini, right? For thesis abroad, it has a lot of variety. So there are cases where you go to a professor you would like to do a thesis with, or with the professor which subject you would like to do a thesis with, and he might have a collaboration with the target university and send you to that target university. On the other end, you might have connections with an external university, and you go there and you ask a professor before going there whether this professor at Polimi will present your thesis before going there. I'm telling this because I have right now a case of a student who did the thesis abroad with no one knowing about that, and now he's looking for an advisor. It's kind of late. It also as, it also as for companies. If you go abroad to a university which does not require you to find any novelty, when you come back, the thesis might be evaluated as a thesis without reviewer. If the university abroad asks you to do some novelty, it will be evaluated as a thesis with novelty, and that is with the reviewer. That's the point. So it holds everything. I have a student doing the thesis at ATH, students doing the thesis in France, and I always do this, let's say, kind of discourse. Obviously, I cannot take all the students that go abroad doing the thesis in machine learning. This has to be shared with my colleagues as well. Otherwise, I would be keeping reading thesis done abroad all the time. But yes, in principle, that's the way. Either you ask the professor or you find the thesis abroad and you ask a Politecnico professor if he can be your advisor while you are abroad. Okay. Other questions about the class, the course? Okay, you are silent, which is a good reason. It means that everything is clear. Okay, if there are no other questions, I will close here. As I mentioned, first of all, you can keep writing questions also by email if you have doubts. There is one about tailing. Okay. So the question is, we train on patches. So the tiling is this: you take the image, you crop the image in tiles. My suggestion is to have overlapping tiles. Now I'm not doing this because but basically, and then you put them in a batch of tiles like this. Then you get for each tile you get the mask, and then you recompose the image with the mask. Now, at training time, it is not needed to recompose so the training time is this. So at training time, you just focus for each patch on the model. But when you test, you have to go from the image to the full image. So you can you don't need to reconstruct the full image at training time. But since the validation, or at least the testing, that is the result that you send on the website, expect the full image, you have to take the image, tile it, perform inference, and then put it back together. So that's the way you do it. Okay, I hope that this clarify, because at testing time, the image has to match the original mask. Otherwise, you don't get properly evaluated. Okay, hope this clarifies. So training and validation is done on patches. Yes, yes, correct. Okay. What about writing thesis at distance? What does it mean, writing? Thesis is not just writing. It is developing, making experiment, and then discussing the result, and then making models, and then making experiment, discussing the result, and writing. Clearly, this can be done at distance. But usually it is not that effective. But obviously, since March, we are doing like that. I mean, right now, all the theses right now are done remotely, except those that require to assess robots, cameras, and so on, or vehicles. The others can be done remotely. I hope that as soon as things calms down, we will go back in the lab, because sitting next to another student doing research on a different things but working on the same tool allows a lot of exchange of ideas and discussions and so on. Doing a thesis at distance is possible, but introduces a lot of lag, because I mean the PhD students working with you might not be available, or I'm not always available online. While if you do it in the lab, from January, the PhD student office will be in front of the lab. So basically, if the PhD student is available, it's immediate to stand and work in front of the whiteboard, and you have this kind of collaboration. But despite this, yes, it is possible to do this remotely, although they are not optimal, obviously. Okay. 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 If there are no other questions, I will close the session here. We are still available. It takes a little bit of time to answer your emails, because we are over busy with the closure of the semester and other delivery time, but we will reply to you. For technical details about the code and the challenge, please keep me in CC, but write directly to Francesco, who's managing everything. Thanks, Francesco, again. And for everything related to doubts, question about slide, exam, and so on, drop me an email. I will reply you as soon as I can. I think that's all. I know that I have to put on the course website the recording of these question and answer, the recording of yesterday lecture from Francesco, the material from Francesco yesterday, and then the past exams which we have collected. So you can have a look on what to expect. Okay. No further question. Good. I will stop here the recording, and I will make this recording public. I will say that we close this year edition of the course. Thank you for attending, so numerous, more than 100 people up to the very last hour. And see you at the exam. Thank you very much. See you at the exam, and well, keep in touch for anything from now to the end of the course. Bye bye. Thank you very much. Thanks.